Hi, I am Renjilal. Today we have a new physics chapter in 10th standard. Its name is Light, Reflection and Refraction. This chapter is followed by CBSE. So let us have some knowledge about light. Light is a source of energy. We already know that light is a source of energy. And light travels in a straight line. These 2 points are we discussed in the earlier classes. Okay, so light react different methods when they hit on different source. So what do you mean by this? So let us have some different object. Okay, different surface. So in a smooth opaque object means, what do you mean by opaque object? Some of the examples are the mirror, smooth tiles, etc. are some examples of opaque object. Opaque object means if an object is there, okay, if an object is there, the light is entering to this surface. So during this surface, the light is it's not going through the object. It's not go to the object, but it will bend over from this surface. So these types of surface is known as opaque object. Opaque means the light is not enter on that object. Okay, so in that surface, what will happen? The light is enter into the opaque object. So opaque object, the light is enter, it will bend over or bounce back into this same surface. Okay, this process is known as reflection. Okay, the next one is another transparent objects. Transparent object or transparent surface. What do you mean by transparent? So in a film, okay, and some of the glass, water, like substances, the light is enter into that surface. It goes through that surface. Okay, that types of surface is known as transparent object or transparent surface. Okay, so whenever a light is enter to the transparent object, the light is goes through that surface. Okay, this process is known as refraction. So examples of some opaque object is mirror, smooth tiles. Okay. So opaque objects in cardboard, etc. are also opaque object, but in the case of light, it bent over some like a mirror, smooth tiles, etc. Okay, so the glass, water, etc. are the examples of transparent object. Next is reflections of light. Here are some points which are related to reflections of light. Imagine this is a plain mirror or a simple smooth opaque object is here. A ray is entering towards the plane mirror, that is known as incident ray. That means the ray is incident on that plane mirror. Okay, and after the incident, the ray is bounced back to the plane mirror. That particular ray is known as reflected ray. Here, this is the incident ray, and this ray is known as reflected ray. So light is entering to here and reflected from here. Okay, and next is normal. What do you mean by normal? This is, we know this is a plane mirror. Just perpendicular and imaginary line is imagine. So we have to imagine a perpendicular line which is perpendicular to the plane mirror. That is known as normal. This is the normal. Okay. Then next point is the angle between incident ray and the normal is known as incident angle or angle of incidence. Here this angle I is the angle of incident or incident angle. Similarly, when the angle made by the reflected ray and the normal, that is known as reflected angle or angle of reflection, right? So in order to this point we have a law. The law is known as laws of reflection. So in the laws of reflection, first law and second law is present. So in the case of first law, the incident ray, the normal to the mirror at the point of incident and reflected ray all lies in the same plane. So simply the incident ray is there, the normal to the mirror at the point of normal to the mirror at the point of incidence, and the point of incidence means this particular point. Okay, and reflected ray all lies in the same plane. So this is plane. This body is like a plane. Imagine this body is a plane. So incident ray is there and reflected ray is there. The point of incidence points of incidence here, these all are lies in the same plane. This explains the first law of reflection. Okay, first law of reflection. Once again, incident ray, reflected ray and points of incidence all are lies in a same plane. Okay, next is second law. The angle of incidence is equal to the angle of reflection. That means here angle of incidence is I and angle of reflection is R. So angle of incident is equal to angle of reflection. Angle of incidence is equal to angle of reflection. That is the second law of reflection. Right? Different types of mirrors. There are mainly two types of mirrors. One is plane mirror and spherical mirrors. Okay. Plane mirror, we already know about plane mirror, plane surface. Okay. But in the case of spherical mirrors is come from the sphere. Imagine this is a sphere which is made up of glass. Okay, cut into two pieces. We get one half here and second half here, separating here. So in this case we get a mirror like this and this another mirror like this. Okay, so this is known as reflecting surface of this mirror, and reflecting surface of this mirror is another mirror is this. Okay, so when a reflecting surface is inverted or curved, that types of mirror is known as concave. The reflecting surface is inverted or caved, that is known as, or curved like is, okay, this is known as concave. And the case of this mirror, the reflecting surface is bulged. Okay, bulged outward. Okay, bulged outward. So it is known as convex. So spherical mirror is again classified into concave mirror and a convex mirror. In the case of concave mirror, the reflecting surface is inverted or curved. Okay, in the case of convex mirror, the reflecting surface is bulged outward. Write some peculiarities of plane mirror. So image is a virtual. In the case of plane mirror, image is virtual. What do you mean by virtual? Imagine this is a plane mirror. An object is here. An object is here. We represented O. And image is there. An image is there. Okay. We represented as I. The object is here and the image is, we know the image is behind the mirror. Okay, we imagine that the image is behind the mirror. Okay, this is an imaginary image. That is known as virtual. Imaginary image. Actually, this image is not behind the mirror. Okay, we seen this in the behind the mirror. Okay, so next is erect. What do you mean by erect? Erect and invert. What do you mean by erect? Erect means here, like object is there, image is there. This is same. But in the case of inverted, inverted means what do you mean by head is here. Okay. Okay. This is inverted. And this is erect. Okay, inverted and this is erect. So you have erect. Image is here and object is like this. Okay, image and object is like this. Next one is distance between the object and mirror is equal to distance between the image and mirror. So this is a mirror. The distance between object, this is object, distance between object and mirror is equal to the distance between image and mirror. This is the third point of the third peculiarities of the plane mirror. And size of the image is equal to size of the object. This is the object size of the object, same size. So same size is the of the image. Okay, if object and image size are same, object and image size are same in the case of plane mirror. So next one, image is laterally inverted. Image is laterally inverted. What do you mean by laterally inverted? Suppose we already see the ambulance like this. So in the case of ambulance, they written like this. So what is the purpose of this? Thus, so when this image, this object, this is the object of that substances. Okay, these are written in the ambulance front. Okay, so this letter is in a plane mirror. In a plane mirror, so the plane mirror, this object is seen like this as an image. So laterally inverted means this right is in the case of left, means the right hand here in the case of right hand, in the case of left hand seen like right hand. Okay, left hand, when an image is like this, okay, when an image like this, okay, its object is like this. Clear? That is known as laterally inverted. Let us more about concave mirror and convex mirror. We have a concave mirror here and a convex mirror is also there. So in the case of a concave mirror, all the rays, all of the parallel rays entering to the concave mirror is reflected and meet a particular point. Its name is focus. We discuss in later. Okay, all the incident rays are reflected into a particular point, meet a particular point. Means all the rays are converged. All the rays are converged. So the mirror is called converging mirror. Converging mirror. But in the case of convex mirror, when a parallel rays are entering to the convex mirror, its reflected rays are moving outward or diverge. So the mirror is also known as diverging mirror. So concave mirror is a converging mirror, convex mirror is a diverging mirror. Right? So some terms about concave mirror and convex mirror. So here let us an axis which cut the concave mirror into two halves. Okay, this particular axis is known as principal axis. Principal axis. Principal axis. Here is also principal axis. This is principal axis, which cut the convex mirror into two halves. Okay, and we already know this is a sphere. In a sphere, the full this has a sphere. So some parts of this sphere is this concave mirror and the convex mirror. So on that particular sphere has a center. So imagine this sphere has this full sphere has a center. This is center of curvature. Is known as center of curvature, notated as capital letter C. Capital letter C. Okay, capital letter C. Here is also in this sphere, full sphere has a center, that is known as center of curvature, capital letter C. Capital letter C. Okay, then an imaginary point or a point, which means the principal axis coming to meet in a concave mirror. In a concave mirror, the principal axis meets in a particular point. In a concave mirror, that is known as pole, capital letter P. Important, capital letter P. Okay, so the pole is the point at which the principal axis meet on a mirror, spherical mirror. Here is also the principal axis is there. It meets in a particular point in a convex mirror. Here's convex mirror, is mirror. Okay, that particular point is known as principal pole. That particular point is known as pole. Capital letter P. So from pole to the center of curvature. From pole to the center of curvature. It is important, not center of curvature to pole. How we discuss in the next class. The sign convention. During sign convention, we measure the pole, the distance from pole to the center of curvature. Pole to the center of curvature, we call it as radius. Radius of curvature. Okay. So from a mirror, pole to the center of curvature, the distance is known as radius of curvature, notated as capital letter R. Capital letter R. Here is also, in the case of convex mirror, here the distance between pole to the center of curvature is R. Radius of curvature, capital letter R. Clear? Capital letter R. Next is, in between the pole and the center of curvature, the middle of the pole and the center of curvature, there is a point. Okay, here there is a point where the where the all converging rays, reflected rays are meeting in a particular point. Okay, we already discussed in the starting. That particular point is known as focus. The converge in a particular point. It is known as focus. Okay, capital letter F. Important, capital letter F. And the distance between pole and this capital letter F, focus, is known as focal length, is notated as small letter f. Distance between pole and focus. Distance between pole and focus. P to F, capital letter F. That's known as focal length, small letter f. Notated as focal length is notated as small letter f. Focus is notated as capital letter f. Focal length is notated as small letter f. Here, some problems. Okay, where the focus is the occur. So all the rays are coming here. All the reflected rays not meeting in a particular point in the case of convex mirror. Okay, so imagine the parallel rays are coming towards the convex mirror, and all the reflected rays are moving outward. So when we meet, imaginarily meet in a particular point, actually it is not okay. Imaginarily meet in a particular point or converge. These all the points are converged here, which means from this this point, from a particular point, all the reflected rays are originated, imaginarily originated. That particular point is known as focus. Okay, here all the particular points. Okay. So the center of curvature and pole, the middle of the center of curvature and pole. Okay, the particular point here is also focus. Okay, similarly the distance between the pole and focus is known as focal length. Okay, this is radius of curvature, focal length. Clear? This is an imaginary image. Okay. So these are about the concave mirror and convex mirror. So important relations also there. The relation between focal length and the radius of curvature. We already know in the case of concave or convex mirror, we don't discuss in the convex mirror. Here we discuss in the concave mirror. Okay, both are same. So we already say that the focus is the middle of the pole and the center of curvature. So from the pole to the focus, okay, is same as from the focus to the center of curvature. Both the length are same, which means from poles to the center of curvature we call it as radius of curvature r. Radius of curvature r. So just half distance is the focal length. So r is half of so here focal length is just half of the radius of curvature, or the 2 is taking this side, so r is equal to 2f, or focal length is equal to radius of curvature, half of the radius of curvature. Means radius of curvature is the 2 times of focal length, and or focal length is just half of the radius of curvature. Right? This is for today. We discuss in the next class. Thank you.